Hi everyone, this is Monica Bansal from Bullseye. I have been guiding my students for last 10 years on various aspects of quantitative aptitude. Today we are going to discuss logarithm, an important topic for all the competitive exams. In this session, we'll be covering all the basic things of logarithm. Before starting, let's have an overview of the session. First of all, we will learn meaning of logarithm. Then we will learn some rules of logarithm. Then there will be examples based on logarithm. Then we will learn how to find number of digits in a number. Then you will have some practice questions and the answer key. So let us start. First of all, let us learn the meaning of logarithm. I'm taking a very small example. It says, how many 3's do we multiply to get 81? Very simple this is. Simple question, normal calculation. 3 into 3 into 3 into 3. So if we multiply 3 4 times, we'll get 81. That is the answer to this question. So we need 4 times 3's to get 81. So we can say the number of 3's we need to multiply to get 81 is 4. Very simple it was. Now we are relating this thing to log. Now it says that if 3 raised to power 4 is 81, in logarithm notation we can write it as log 81 with base 3 is equal to 4. You can see this 81, that is a resultant here. This 3, that was the base here, and the answer, that was 4, that is the power here. So if 3 raised to power 4 is equal to 81, we can say that log 81 with base 3 is nothing but 4. Now let us see the notation. So we can say that if log x with base a is equal to n, that implies a raised to power n is equal to x, and vice versa is also true that if a raised to power n is equal to x, we can say log x with base a is n. See, power is coming here. Okay, now let us see some rules on logarithm. The very first rule says log a raised to power x with base a. This is base here. This is equal to x, and one more similar rule, a raised to power log x with base a. That complete thing is in power, that is also x. So these are two important rules. Now coming to second rule, we call it multiplication rule of logarithm. Log x, y, they are in multiplication with base a. This is equal to log x with base a plus log y with base a. Then we have division rule. If log x by y with base a, this is equal to log x with base a minus log y with base a. So what is the thing? This is, if you have multiplication, then you will put a positive sign here. If you have division, you will put a negative sign here. Now coming to next rule, it says, we call it power rule. Log x raised to power p with base a, it will become p log x with base a. Power will come in front of log. Now the next thing, we call it base changing formula. It says log x with base a is equal to, see, we are changing base here. Earlier base was a, but on right hand side base is b. So we can write it as log x with base b divided by log a with base b. This is called base changing formula. Now we'll do some applications of this rule. And one more thing, log x plus y with base a is not equal to log x with base a plus log y with base a. I mean, this is not normal addition or subtraction. We have different formulas for logarithm. We cannot apply simple general arithmetic operations in logarithm. So please, we can say that you can see this, that log x plus y, that is normal addition, but we cannot take this as log x plus log y. Similarly, log x minus y, this is not equal to log x minus log y. Similarly, all the rules are same for multiplication and division. So let us move. The very first question, very easy it is. Simple log application. It says log 64 with base 2. We want to find the value of this thing. So if we go by definition of log, how many times do we multiply 2 to get a 64? Simple. We can say that we multiply 2 6 times to get a 64. So what should be the answer in this case? It will be 6. But if we apply formula that we have learnt in the earlier slide, we can write this as log 2. 64 can be written as 2 raised to power 6. Now we are applying power formula here. It will become 6 log 2 with the same base 2. As we know that log a with base a is always 1. So it will become 6 into 1. This will be 6. So how many formulas we have used in this question? There are 2 formulas. Once again, the very first formula is whenever you have log a with base b to the power x, it will become x log a with base b. That is the first formula we have used. And the second formula is log x with base x. If the base is same and the number is same as well, it will be 1 only. So answer for this question is 6. Now coming to next question, a similar one. Simply we can go by definition of log. If 5 multiplied 3 times, we'll get 125. So what will be the answer to this question? It will be 3. But if we apply formula here, so this number can be written as 125. As you know, this is 5 cube. By power formula, it can be written as 3 log 5 with base 5. Further, this can be written as 3 with the same reason. So what will be the answer for this question? It will be 3. Now moving to next question, it says if 10 raised to power log 9 with base 10 is equal to 8x plus 5, then find the number of values of x which satisfy the given equation. It's a pure formula application. So if we take given equation, it is in the previous slide we had a formula that a raised to power log x with a are same here. Answer will be x in that case. That was the very first formula. That was the very first rule in earlier slide, rule slide. So this number can be written as 9 is equal to 8x plus 5. Now simple equation, that is a linear equation. As we know, we have only one solution to a linear equation. That will be 8x is equal to 9 minus 5, which comes out to be 4. So x will be half in this case. See, the solution is not asked. We are not interested in finding value of x. Rather, find the number of values of x. So what will be the answer in this case? It will be 1. Now the next question. Let x is equal to log 2 with base 10 and y is equal to log 3 with base 10. With the help of these two values, we want to calculate log 12 with base 5. And the options are also given in this question. So let us see. See, you can see here that all the options are in the form of x and y. So we want to make use of these two values, log 2 with base 10 and log 3 with base 10. Now this is asked. log 12 with base 5. See, the values which are given, they are in base 10. So we want to make use of base 10. So we are applying base changing formula here. This number can be written as log 12 with base 10 divided by log 5 with base 10. Now, since 12 can be written as 2 square into 3, and we don't have any value for log 5 with base 10, but this 5 can be written as 10 by 2. So, if we apply further formulas of log, this can be written as, I'm applying in the denominator the product formula, and in the denominator we are applying division formula. Also, this expression, the first expression in numerator, we can apply power formula here because we have value for log 2 with base 10, but in this expression we have 2 square. So this 2 can come here, which will become 2 log 2 with base 10. So this expression will become 2 log 2 with base 10 is x by equation, plus log 3 with base 10, this is y, division by log 10 with base 10 is 1, we have discussed it, minus log 2 with base 10 is x. So what will be my answer in this question? It will be this option, 2x plus y divided by 1 minus x, which was third option. Now let us move to next question. It says evaluate log root 3 with base 243 plus log 2401 with base 7. First of all, let us take the easier expression, that is this. Second one, since we know that 7 raised to power 4 is 2401, that's why this can be written in this manner. Now by using power formula, we can write it as 4 log 7 with base 7. And we know log a with base a is always 1. So it comes out to be 4. So in the given expression, in the given two expressions, the second expression comes out to be 4. Now let us go to the first expression. It says log root 3, which can be written as 3 raised to power half. I'm introducing a dummy base here, let it be a. It can be anything. I'm using base changing formula here. So we can write the given expression as log 3 raised to power half with base a division by log 243 with base a. Now it will become log 3 raised to power half with base a division by, now 243, this is 3 raised to power 5. So we can write it as log 3 raised to power 5 with base a. Now time to apply power formula here. It will become half log 3 with base a division by 5 log 3 with base a, which comes out to be 1 by 10 because these two terms are cancelled. Now addition of both the expressions, that is asked. So we can take the addition. It will become 1 by 10 plus 4, which comes out to be 41 by 10. So 41 by 10, that is the answer in this case. Now next, an equation based on logarithm. It says if log with base 4 log 36 with base 6 is equal to log 4 with base x, find x. So first of all, let us solve the left hand side. Since this expression, it can be written as log 6 and 36 can be written as 6 square. So that is a complete expression. By using power formula, we can shift this to here. So it will become log 4 to log 6 base 6. And we know that log 6 base 6 is always 1. So it comes out to be log 2 with base 4. Now, how to calculate log 2 with base 4? See, we can change the base here. We can write it as log 2 with base A, log 4 with base A. Now, this can be written as log 2 with base A, and this can be written as log 2 square with base A. Now, by using power formula, we have done this. It will be 2 log 2 with base A in the denominator. So, it will become half. So, left hand side, that comes out to be half in this case. And now this is equal to log 4 with base x. So it becomes log 4 with base x. This is equal to half. You can further apply formulas, or you can apply the definition of logarithm. If we apply definition, it will be nothing but x raised to power half is equal to 4. If x raised to power half is equal to 4, x will be nothing but 16. So what will be the answer in this case? It will be 16. Now the next question, a new concept by using logarithm. See, question says find number of digits in 2 raised to power 10. 2 raised to power 10 is an easy value. We know the value of this number. This is nothing but 1024. So answer to this question is very easy, that is 4. See, how can we apply logarithm here? Whenever you want to find number of digits in a number, take log of that number. For example, 2 raised to power 10, that is the required number here. We'll take log of this. See, whenever I am not defining the base, please consider it as 10. So this is nothing but 10. So by using formula, power formula, it will become 10 log 2 with base 10. And log 2 value that is given, again, if nothing is mentioned in the base, it is advisable to take base as 10. Now its value is given as 0.3010. Calculate the final expression, which comes out to be 3.010. Now the last thing to be done here, see, find the log of the given number, find the final value, leave the decimal part. See, that is important. Leave the decimal part, take only integral part and add 1 to this, which comes out to be 4. So how many digits are there in 2 raised to power 10? They are 4. Now you have some practice questions. And this is the answer key. For more such videos and more such concepts, please log on to hitbullseye.com. Thank you so much. Happy learning.